Okay, so we'll start with the rules for the derivatives of exponential and logarithmic functions. Let's name the basic or the general expressions. If y is in the form of a raised to x, the derivative of this dy over dx is ano siya? A to the x and then ln of a. So it's the expression itself times the ln of the base a. So example, if y is equal to 2 raised to x, then dy over dx, the derivative is 2 to the x times ln 2. And that's the rule. Do you understand? This exponential equation can be extended to y equals e to the x, wherein the derivative of y with respect to x is, so by the rule, e raised to x ln of the base e. But ln e is equal to, it's a special value. Ln e is 1. So the derivative is also e to the x. So what did you notice here? Y equals e to the x. The dy over dx is equal to e to the x. So they're the same because of the nature of the base e. If we get ln e, that's 1. So y equals e to the x, derivative is e to the x. Okay? Understand? But let's make it more complicated. Well, not that complicated. Another example. 3 raised to x squared plus 2x. Let us introduce an exponent that is no longer just x. But this is still an exponential equation or function. So it must follow the rule for the exponential functions. dy over dx is equal to, diba, by the rule, it is the expression plus 2x times ln of the base. However, like the chain rule, we still have to multiply this by, anong kasama niya? Derivative of the x squared plus 2x. 2x plus 2. Diba? Chain rule pa rin. 2x plus 2. Another one. Y is equal to 3. Wag naman 3. 1/2 raised to tangent x. What is the derivative? 1/2 tangent x times ln of 1/2, but there's a tail, times secant squared x. So yan na siya. We are just using the rule. Okay, now we go to the logarithmic expressions. So what if we have y is equal to log base A, any base A, acceptable base A rather, because A cannot be 0, a should be greater than 0. Actually, a should be greater than 0. Yeah, that would be positive. Okay. Can it be 1? Can it be 1? Actually, we have to restrict. But a cannot be equal to 1. If a is equal to 1, then everything will be the same. Okay. So, but the rule says, if y is equal to log base ax, then dy over dx is equal to 1 over x. And then down below, we also have ln of the base. So ln is in the denominator, ln a. Example, y is equal to log base 2 of x. Dy over dx is equal to 1 over x ln of 2. And that's the answer. And let's see what will happen if the base is e. Log base e x. Note that log base ex can be written in a different way. If the base is e, then this is ln x. This is what we call the natural logarithm. If the base is e, so it's a natural logarithm, so it's written as ln x. But let us apply the rule first on the log version of the expression so that we can see what will happen. Dy dx is 1 over x ln of the base, but the base is e. But what is ln e? 1. So it's 1 over x times 1, or simply 1 over x. And so now, since log e x is equal to ln x, then if y is equal to ln x, then dy over dx must be 1 over x. That's the shorter version. Siya. Every time you see ln x, the derivative is 1 over x. So if I have y is equal to ln of 2x squared plus 3, then dy over dx is equal to 1 over 2x squared plus 3, and then that's it, diba? Times the tail. There's no more ln e, so then it's 2x squared plus 3 times 4x, and then the 3 will just be 0. Derivative of 3 is 0, constant. Okay, can you follow? Or if it is written in terms of log base 0.5 of sine 2x. Then dy over dx is equal to 1 over sine 2x ln of 0.5 times, there's a tail, cosine of 2x, and also times 2. double chain rule, di ba? Chain rule na yung sign para maging cos. Pero meron kasi nasa loob. So yung the chain rule, di ba? Yes. Yeah. And then we can just rewrite this as 2 cosine 2x over sine 2x ln 0.5. How else can you write this without using two trigonometric expressions? Cotangent, very good. So this is 2 cotangent 2x divided by ln of 0.5. Yan. Kasi yung cosine saka yung sine, they have the same expressions, but cosine over sine is cotangent. Okay, so that's how you get the derivatives of exponential and logarithmic functions.